Good morning and good evening, everyone. I'm Nick Lowe. I'm an SE based in Western Canada. Today, I'm introducing VSX support for the CX 6300 series and AOS-CX 10.16 10.05. This is something many of you have been asking for, so we'll go through together what it means, why it matters, and how you can use it. We'll then wrap up with a demo so you can see it in action. So here's the plan. We'll start with a quick overview of what VSX on 6300 actually is. Then I'll hit real use cases and why customers care. We'll cover a few details and caveats so there are no surprises, walk through the configuration flow, and share best practices and troubleshooting tips that save time in the field. We'll cap it with a short demo and a couple minutes for questions. So let's get into the overview. So for those who are unfamiliar with VSX, it's short for Virtual Switching Extension. It essentially allows two physical switches to operate as a single logical system for L2 and L3 redundancy. You get active-active redundancy, simplified design, and non-disruptive upgrades. It's been on our higher end CX lines for years. So the headline today is with 10.16 10.05, VSX comes to the CX 6300F and 6300M series of switches. So you can extend HA deeper into the campus. So just a quick note, and it is an important one, and you'll hear me call it out a couple times, is that the 6300L models are not supported for VSX. The 6300 VSX is supported on all SKUs of the 6300F and 6300M. Again, the 6300L is excluded here. Everything else you know from VSX on either the 8300 series or 8400 series of switches conceptually apply here as well. So let's pivot into use cases. So first, there's no hardware refresh. If your customer already owns a 6300M or 6300F, they can light up VSX and get HA without swapping gear. Second, it's better uptime. The active-active model gives you fast failover. Third, it's design flexibility. You can either pick VSF or VSX based on what you need. Just remember they're mutually exclusive at boot, and we'll be talking about this shortly. At the edge, we typically see this feature used for remote sites and multi-tenant environments where you still want redundancy. You also get live upgrades with minimal disruption. MC lag for dual home devices, and a logical VTAP option for VXLAN resiliency. The net result is a simpler L2 and L3 design without the spanning tree gymnastics. So now let's take a moment to review the differences between VSF and VSX stacking technologies. So the way to think of it is VSF is one brain across multiple boxes. You can manage it as a single switch. It's easy, but the whole stack shares one control plane, so upgrades or failures can impact everything. VSX is two brains with a shared active-active data plane over the ISL. Each switch keeps its own management and control, so you get MC lag, Anycast gateway, and live upgrades with a smaller blast radius. So the general rule of thumb here is that VSF is for the access layer, and VSX is for the aggregation or core layers, or anywhere uptime and dual homing and VXLAN actually matters. So let's get into the details and caveats. So VSX on the 6300 requires AOS-CX 10.16 10.05, as Shabana had shared, or later, and supports all 6300 F and M models. There's a new boot profile mechanism that lets you toggle between the default VSF profile and VSX profile. That profile change ensures only the right services come up at boot for VSX. As such, when toggling between VSF and VSX boot profiles, the startup config will be wiped and the switch will be rebooted. So this is going to be important. We'll be discussing more about boot profiles in the next few slides and in the demo so it's crystal clear to everybody. REST API is also supported to configure and monitor the switch. The VSX sync command can be used to synchronize key configs between peers, eliminating config burden. And finally, for the VSX ISL and Keep Alive, any interface can be used. The out-of-band management ports can also be used for the Keep Alive if desired. So let's transition into the boot profile behavior. So historically, auto starting VSF services at boot created dependency conflicts for VSX. The dedicated VSX profile fixes that by initializing only VSX related services. So the key takeaway here is pick the right profile before you start configuring the switch, and the commands only appear in the matching profile. So as you can see from the window below, executing show profile available shows two profiles. One is called basic and the other one is called VSX. Basic implies VSF, and it's essentially the stacking technology that you already know and love about the 6300. Show profiles current displays the current running profile. So in this sense, because it's basic, it's actually running VSF. So the command introduce is profile. Profile takes one of two arguments, either basic or VSX. So when entering profile VSX, you're prompted to select yes or no, in which case the switch will wipe the config and reboot the switch. Now for the caveats. Switching profiles always clears up the startup config and reboots, as we just mentioned. VSX configuration is CLI only for now, and the 6300L isn't supported for VSX. Don't paste VSX configs into models that don't support it. The local web UI can only display VSX status, and note that extended VMAX aren't available. Also, with HPE Aruba Networking Central and New Central, they do not manage VSX configurations at this time. Now let's get into the configuration flow. We'll start by building the profile, the ISL, the keep alive, as well as the roles. First, we want to verify the current profile. If it's basic, VSX commands won't exist yet, of course. Upon executing profile VSX, confirm the warning and let it reboot. The config is cleared by design. When it comes back online, show profile current should read VSX. And now show VSX commands are available. With the profile set, let's build the pair. Okay, let's start by reviewing a sample VSX configuration. The left side of the screen will be a primary switch and the right side will be a secondary. We'll start by executing profile VSX, entering Y to confirm clearance of the configuration and reboot of the switch. And then under the interface lag 256 context, which will be our ISL, I'm going to be trunking all VLANs and leaving the native VLAN as 1. It's important that we enter LACP mode active to establish that lag automatically. And then I'm going to map lag 256 to the physical interfaces. So notice here that the primary is a 48 port switch, therefore the optical will be 49 and 50, and on the secondary 25 and 26, reflecting a 24 port switch. And then under the VSX context, we are in fact specifying that the ISL will be lag 256. We are also configuring our keep alive peers, and notice that I am putting them under the VRF management instance. We're going to be specifying the roles as well. So the primary will be the primary and the secondary will be the secondary, and the virtual max can be the same. And then finally, I am configuring active gateway here. So the interface VLAN 2 will reflect the data VLAN. I'm going to be specifying the virtual max and IPs, which will be the same on both the primary and secondary. The only difference here really is the SVI IP addresses. We will be walking through how to configure all of this in our demo. Okay, let's shift into recommended best practices. So here's a checklist that I typically use in the field. So you want to keep both peers on the exact same AOS-CX version and reserve high-speed links, either 50 or 100 gig in this context if we're talking about the 6300. And that's for ISL. Put the keep alive on a physically separate path and VRF. So in my example, I put it on the management. Enable VSX sync for VLANs, lags, ACLs, and other shared objects. Use MCLAG consistently for downstream connections. Mirror any L3 routing on both peers so routing looks identical to the rest of the network. Before changes, grab a checkpoint and backup. Even with live upgrades, schedule a window. For further best practices, you may refer to the VSX Best Practices Guide, which we will include in the slide deck. So let's cover verification commands you'll actually use, and then we'll start at the boot profile than VSX states. So 2 quick checks. The show profiles current command confirms you're in VSX, and the show profiles available shows that you're either in basic or which implies VSF and VSX options. If you're not in the right profile, no amount of VSX configs will work. I listed the more common VSX commands here as well. It's not an exhaustive list by any means. There are tons of resources available. The user guide, config guide, best practices guide, validated solutions guide, and the REST API guide is referenced below in the hyperlink. So here's what the output would look like when healthy. The current profile reads VSX. Available profiles list both basic and VSX. If you are in basic, stop and change the profile first before proceeding. This is your primary health view. It shows the ISL state, config sync state, software versions, and local or peer roles. You want ISL and config sync to read in sync. This command validates the out-of-band heartbeat. It look for the keep alive established and clean counters. No timeouts, no drops. If this flaps, move it to a truly independent path or VRF. The brief view is a nice at a glance. It shows the ISL state, keep alive state, device role, and MC lag count. So let's get into the demo. So here's the pair of 6300s. Just in my example, the left will be the 6300M 48 port, and the right will be the 6300F secondary, which is a 24 port. The ISL will be configured across 49 to 50 on the left and 25 and 26 on the right. So they're going to be using the optical 10 gig ports. A separate keep alive path on the management and MC lag down to the host will be configured. I'll start by showing the VSX status and a quick ping, and we'll trigger a failure. So what we're going to be doing is rebooting the primary node, and we'll watch for the host to see if the connectivity is kept up and healthy. LACP will rehash, active gateways will be up, and forwarding continues on the secondary node. We'll verify with counters and a live ping. So with that, we will transition over to our demo. Great, so we're going to be building VSX from scratch. So what you saw in that topology there is what we'll be essentially providing in this demo. So first we're going to execute show profile, which shows the show profile available, which shows the current profile. So in this case, it's basic and VSX. So we are running basic, as you can see there from the show profile current command. So we're going to go ahead and go into the configuration context and execute profile VSX. So if you recall, basically this command, what it does is it clears the config and reboots the switch. We're going to do the same thing on the secondary switch, which resides on the right there. So once it's up and running, you can log in and then execute show profile current, which should show VSX. So step 1 is complete. So step 2 is to create the ISL lag. So I'm going to put a host name first, so it's easier for us to distinguish between the two switches. And then I'll enter the interface lag context. I'll ensure that it's in L2 mode, activated, and trunk everything. And I'll have LACP mode active, enabled. I'll do the same thing on the secondary node. Step 3, we're going to assign the lag to the physical interfaces. So again, on the switch on the left here, that's a 48 port. So I'm going to go ahead and link lag 256 and set the L2 MTU settings. As you can see, they are both up. We're going to use the optical 10 gig links. And on the right, we are going to reflect the same configuration. And it should be in an up state as well. Okay, the fourth step is to configure the ISL keep alive IP addresses. So in this case, I'm actually going to be leveraging the interface management port as well. And I will make sure that they both are on the same subnet. I'm using a /30 here. Step 5 is to configure the VSX. So we're going to go into the VSX context, specify that lag 256 that we created is going to be the ISL, specify the keep alive and the roles, as well as the VMAX. Once done on the primary, we are going to reflect the same configuration on the other end. So we can review the show VSX status command. Right now, you'll see that it's out of sync. It does take a few seconds. And the secondary is in sync, so we'll go ahead and refresh that. And they are both in sync for both the ISL channel and config state. We'll take a look at the keep alive as well. It should say keep alive established, and it does. Okay, step 6 is to configure the active gateway. So notice here that I created a VLAN and I drilled down to the VLAN context and enabled the VSX sync. And so that basically propagated the data VLAN 210 over to the other side. So go into the interface context, configure the virtual MAC and virtual IP address, the L3 MTU settings, and the actual IP addresses for that SVI. We'll do the same thing on the secondary node. So look at the config sync. It is enabled and operational. Perfect. So step 7 is to configure the MC lag link. So I'm going to demonstrate how to configure this on the downstream devices, which has a switch connected as well as some wired assets. So I have, basically I'm putting the 210 as an access VLAN for that MC lag. I'm going to the MC lag context, of course, enabling LACP fallback as well as root guard. So if a superior switch comes into play, this will retain its root configuration. And I will configure the same thing on the secondary node. So we're going to take a look at the LACP interfaces to make sure that it is active. So upon review, you will see that the lag 2 that we had created on both sides does reflect healthy states. So this is what we're going to do. We're going to shut down the primary node here. So this is step 8, simulating a failure. So go ahead and take a look at the VSX states again, as well as the interface VLAN 10 to make sure everything is up and active, as well as review any virtual MACs and virtual IPs. So at the bottom here, I'm basically RDP'd into one of the machines connected behind the switch in MC lag mode. And then I'm running a program called Ping Plotter that will verify the connectivity to Google and Twitter. So you'll see in Ping Plotter, the count at the bottom left there will continue to go up. And if the status isn't green, it's good. So I'm going to reboot the switch. So now it's currently being rebooted. Therefore, we'll reflect a failure. So the important thing here is what we want to see, again, is green is good. There's no ICMP drops. Really, the traffic is being sent over to the secondary node through that L2 LECP hash that we configured in the MC lag mode. So far, so good. So I'm going to run a repeat command and wait for the ISL to be in sync. And there you have it. No ping drops. Perfect.